Hello, everyone. Sorry about all of the faffing around. I really liked the email analogy with Interledger. So I guess that would make Rafiki like postfix. If any of you remember the good old days of setting up postfix, I use that term very loosely, which I guess kind of makes Tiger Beetle like the mail-dir storage format. Not really sure how far we can stretch this analogy. Anyway, I thought we'd start off with a game of GeoGuessr. Does anyone have any idea where or what this is? Any guesses? Uses a lot of power. Data center. Any idea where or who owns it? Amazon? So this facility actually forms part of US East 2. It's about 300,000 square feet, I believe, and out of all of the hardware they have in there, one piece of them is the Intel's creatively named Intel Xenon 8375C Ice Lake version that has 56 megs of L3 cache, 1.25 megs of L2 cache per core. Now, it doesn't quite work this way, but that's actually enough cache to meet the minimum memory requirements of Windows XP. So, I'm Federico from Tiger Beetle, and this is where the Beetle meets the road. Over the next 20 minutes or so, I'm going to try and show you how Tiger Beetle makes light work of various financial use cases. Last year, Joran went into the why and the philosophy that was driving Tiger Beetle. Today, I actually want to show you the results of that focus. I also want to show you how you can use Tiger Beetle to track financial transactions at scale and how that compares to a world before Tiger Beetle, and how it compares to if you had to build your own database, your own financial accounting database on top of something like Postgres. But I'm also here to answer one very important question. Who would win? A 10 nanometer processor with a PDP of around 300 watts? Or Raspberry dessert? Before I get on to that, let me just give a sort of refresher on some of the details of Tiger Beetle. So one of the key aspects is its domain-specific nature. In Tiger Beetle, we have accounts, we have transfers. I was at this database seminar in Germany last week, and it was all about focusing on ensuring the reliability and robustness of database systems. It was great, but about half of the time there, the focus was actually on SQL, the standard, and the language, not even on the database systems themselves. On the last night, we actually played a game of Database Jeopardy, and one of the questions for $200 was, what is 1,000 pages of easily accessible documentation that is always ignored by every vendor out there? And the answer was the SQL standard. So Tiger Beetle instead has a fixed double-entry accounting data model. A transfer debits one account, and it credits the other. Simple, double-entry accounting. We do support more advanced features. We have linked transfers, we have pending transfers, we have other flags, we have balancing transfers. But for the purpose of this talk, and also because I don't really feel like re-implementing those in SQL, we're not going to cover them. So anyway, this was just a little diagram showing we have two accounts here, debits posted, credits posted. If we do a transfer between them, the end state ends up looking like that. Very simple. This fixed schema ties really well into performance. So time is money, and performance actually buys you time. But more than that, performance buys you safety. What do I mean by this? If you're running a system that's on razor-thin margins, you have no room for error. If there is a spike in traffic because of something like Singles Day, Black Friday, your system can easily be pushed over the edge. You can have cascading failures, thundering herd, all of that great stuff. It also means that when you're running a system that has fine margins like that, you truly need to understand all of the little details. You need to know what things like auto vacuum multi-exact freeze max age does in Postgres. Tiger Beetle excels at the sort of high contention workloads for that payment systems typically deal with. So think of like a payment switch that has 2 hot accounts. Now, if you've actually run a hobby website, maybe set up a blog that maybe your mom visited once a month kind of thing, you kind of know the feeling of not needing to worry about operations, right? You deploy MySQL on your VPS, maybe it has a gig of RAM if you're lucky, costs $5 a month. You don't worry about tuning knobs and setting things and worrying about buffer pool caches and all sorts of other random parameters. And that is one of the core feelings that we're trying to go with for Tiger Beetle, and that's what performance can buy you. So, enough with the introductions. This is meant to be a demo slot, so I guess let's kick it off with the demos. I think the best way to kind of show a lot of the things we've been doing is with benchmarks specifically. The problem with benchmarks is that they're gamed very easily. So if you see anything that I'm presenting that looks rigged or unfair, please call me out on it. Also, another quick disclaimer, while every effort has been made to ensure a smooth viewing experience, I'm dealing with some pretty finicky hardware that's under the handkerchief there. So I guess if anything doesn't work, it'll at least make a good meme. Oh no. Okay, so you might have seen that little bar going at the top saying about 300 TPS or so. That's actually a benchmark that I started a few minutes ago. It's running on a, let me actually move my annoying mouse out the way. It's actually running on a RDS cluster in Amazon, Postgres. Each of the instances has 16 gigs of RAM, 4 cores, 100 gigs of storage. It ends up costing about $542 a month, which as far as cloud cost goes, is actually pretty cheap. The traffic is generated by a Python script. I'll show some snippets of that as we go on. But it's running on an instance in the same availability zone for the lowest possible latency. Now, the test for both Postgres and Tiger Beetle here is simple. We have 2 hot accounts, and we're doing transfers between them. As I said before, re-implementing the whole of Tiger Beetle inside of SQL is a bit out of scope for this talk. So the schema and the indexes are copied one-to-one, but no other features, including things like check constraints, ensuring debits can't exceed credits, things like that have been implemented. This actually rigs it somewhat in Postgres' favor since it doesn't have that business logic to contend with. So, as I alluded to in the intro, for Tiger Beetle, we have a Raspberry Pi 4B 4 gig model with a 32 gig micro SD card. This little thing costs about $60 all inclusive, once off. Again, great part about physical hardware. Now, you would have to have a lot of courage, definitely more than $40 worth, to try and run a database for payment switch on a single Raspberry Pi. So I bought 3 of them. They're even powered by power banks. I don't actually want to move those because they're a bit precarious, but trust me, there are 2 other Raspberry Pis inside there. So they're completely off-grid as well. The connectivity for these, well, I didn't actually want to fly from Cape Town with an access point and Ethernet cables and all that other networking gear. So actually my phone is just running a mobile hotspot, and they're all connected to my phone, and that's why I have that unsightly Wi-Fi dongle sticking out of my laptop, because it's connected to my phone too. So, let me put this down. And let's talk a bit more about the first benchmark that's still going there. So there are very good reasons to not write code like this, but you'd actually be surprised as how often this can end up in practice, even if unintentional. So what we're doing here is to create a transfer. We have 3 SQL queries for each transfer. we update the credit balance, we update the debit balance, and then we actually insert the transfer. The big problem with this logic is it's not transactional, and Postgres is essentially flushing to disk every time we run one of those queries. The benchmark that's running at the top there, it's done 180,000 transfers now. It is essentially benchmarking the speed of fsync. Let's see how Tiger Beetle and the Pi compare, if this works. There we go. So that number should catch up. And chug, 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 chug. There we go. Made pretty light work of that. Again, this was rigged, so nothing too dramatic there. Let's make things better for Postgres. Okay, so we improve on that V1. How do we improve on it? Well, first we wrap everything in a transaction. Then, instead of actually executing one query per account update or per transfer update, we can execute many, which essentially prepares the query once on the database and then just sends multiple values. So it's more efficient, less chatty on the network as well. We also use copy records to table. This is just the Python wrappers, the Python libraries wrapper around Postgres' copy command, most efficient way of getting bulk data in and out. So let's fire that one up. Creatively named V2. Yeah, and we've gotten an order of magnitude improvement, which is pretty good. But if I run this, well, you can see it is still significantly slower than Tiger Beetle running on 3 Raspberry Pis connected via Wi-Fi. Okay, can we get Postgres here to beat Tiger Beetle? Yes, we can, actually, with a bit of tripping, with a bit of tweaking, rather. So what's tripping it up is the balance updates. Those rows are highly contended. The database has to take out row locks every time it does an update. If we pre-compute those client-side, we can actually get much better performance. So this is what this code does over here. It basically just calculates the balance updates on a per account level and then applies them in one go rather than telling the database to apply it for each thing. So let's stop that and run v3. Whoopsie. So you can see v3 is going way quicker now. We've got in another order of magnitude. We're hitting about 20,000 transactions a second on Postgres. If I run our Raspberry Pi one now, I conveniently added in the TPS number just to keep this a surprise. We are beating Tiger Beetle here. So I'm just going to stop this test because there's kind of, the top one's going to beat the bottom one. This approach does have a few disadvantages, though. So we're relying entirely on client-side logic here, which means a bug in your application could, update a balance incorrectly, which would be catastrophic. If you're using multiple libraries, multiple languages, the surface area of this just sort of explodes. For any more advanced logic, we've also limited ourselves. We're using transactions, and it essentially means that our batch size will become our transaction size. And lastly, this optimization in particular works well for low cardinality accounts, but not for high cardinality accounts. If we have as many accounts as we have transfers, you're not going to gain anything by doing this. So, what can Tiger Beetle do on real hardware? So, let's see here. SSH in here. Run that. So, does anyone think that this is going to be quicker than Postgres? Yes. Does anyone think we can catch Postgres? Maybe. No, I took too long. But I think you get the idea there. So Raspberry Pis are not hardware suitable for running a payment switch, as much as I love them. The micro SD cards are notoriously slow. They have all sorts of other things. The CPU cores are slow, etc. This is a real setup with 3 instances on AWS. These are pretty cheap ones. They're certainly less powerful than the RDS instances that we were showing earlier. And I think the total for all 3 of these total around $250 a month. So, was this comparison fair? Who thinks it was fair? Who thinks it was unfair? Yeah. So it was loaded for Postgres operationally, but actually Tiger Beetle had the advantage here. So B trees, which is one of the core components of Postgres, were invented before 1970. LSMs only came around, the paper was only published in 1996. So LSMs have been around less from when the paper was published to now than B trees had been around when Postgres was first released. And also the other thing is modern NVMe drives are just crazy fast. You can get drives these days, commercial, off the shelf, like order of Amazon, Newegg, whatever, that cost a few $100s and will give you 10 gigabytes a second of write speed. A lot of the optimization work that's been done on engines like Postgres and MySQL has assumed spinning disks, has assumed high latency, and those same optimizations cost it now. We've been fortunate enough to take advantage of all the progression and all the enhancements that have happened since then. So it's really these improvements that give Tiger Beetle the edge, combined with a domain-specific model, first-class batching, and of course, I have to give a shout out to Zig for enabling, systems programming in a more pleasant language than C, shall we say. Then one more thing. So I've been chatting about one elephant in the room, which is Postgres, but the other elephant in the room is when will we have our production release? I think Sabina and I had some DMs on Slack where I said June, and she was like, oh, that's great. And then it's now past June. So we are aiming very much for the end of the year. We've got a lot of critical pieces in place now. We have our release infrastructure in place. We've completed a 100 billion transfers test recently. So that's another advantage of performance, is you can do these tests with these crazy high numbers in a reasonable amount of time. And yeah. Thank you for your time, and any questions?
Any questions that are not by Alex? Okay, there we go.
I think that's good.
That's what he said.
So there's actually one thing I was wondering if that was actually unfair towards Tiger Beetle in the demo, which is a lot of times you have many clients, so you have constraints in accounting databases where like an account can't go negative, for example. And so with the approach of the fastest Postgres implementation, that wouldn't actually be possible to enforce those constraints accurately, I think. So it's actually unfair towards Tiger Beetle, I thought.
Yeah,
correct in that?
That is correct, yeah.
That was a nice short answer. Well, I mean, if there are no questions at the moment, you can go have a coffee break and replenish your brain cells and then come and look for this gentleman with more accounting and Tiger Beetle questions. So break time, everybody. Please come back at 3:30.